Hello, what's going on? We are going to do another equilibrium question. Now, this question, well, similar to questions we've done previously, but then again, this is good practice, it's all about getting good practice. Let's look at this equilibrium system. NO2, N2O4, delta H is negative. Negative means what? Delta H is negative means negative value. This is negative, this therefore this exothermic reaction. So the forward reaction exothermic, reverse reaction is endothermic. Okay. Now the question, okay, let's see what is the question is saying. The reaction system can be observed in a sealed test tube. Though this is a sealed test tube, you have NO2 and N2O4 mixture. In that, NO2 is brown in color, N2O4 in colorless. Okay, so you don't necessarily have to remember the colors. These questions will give you the color of each gas. So when you look at this equilibrium system, since the NO2 is brown, you will see this as brown. All right. Okay. Now, according to this question, which allows the student to investigate the impact of temperature. So we are trying to check the impact of temperature in this equilibrium system. Obviously, you should be placing this in ice and to decrease the temperature, as well as to increase the temperature, you should be placing this in hot water. Now, according to this question, you are placing it with the hot water. Now, the question is asking you, explain why this color change occurs. So obviously there is a color change. Then you need to know what that color change is and why it is occurring. State the color change. You have to say state. You have to say state the color change. All right, now let's analyze this question again. State the color change, 1 mark. Expected when the student places the sealed test tube of a mixture in a beaker of hot water. Explain why this color change occurs. So then there are 3 marks in this question. So let's see how we can get those 3 marks. So we have to firstly state the color change. Now, in order to state the color change of the system, you need to look at what is actually going to happen. Now, before we start writing the answer, let's look at this. Now, forward reaction is exothermic, reverse reaction is endothermic. So when you place it in hot water, you are increasing the temperature. So system will partially oppose the change by trying to decrease the temperature by favoring the endothermic reaction. So the reverse reaction is the one that is going to be favored in this situation, because forward is exo. Then if forward favors, it's going to produce more heat. Now we need to do, what do we need to do? System has to reduce the amount of heat. So that is why that is why it's favoring the reverse reaction, endothermic reaction. When endothermic reaction is being favored, the intensity of the brown color will increase. So we have to say the gas mixture goes darker brown. So darker brown, right? So the gas mixture goes darker brown, or the intensity of the brown color will increase, also correct. Now we need to explain why it is happening. How do you do that? Firstly, you need to say forward reaction is exothermic. Therefore, hence, so we say hence reverse reaction is what? Endothermic. This pen is not good, man. This is endothermic, right? Reverse reaction is endothermic. You need to say that forward is exo, reverse is endo. Okay. Now, by placing it hot water, what are we trying to do? We are increase its temperature. So when temperature is increased, what would the system do? System partially oppose the change. Don't write SPOC. You have to write it properly. System partially oppose the change by trying to decrease the temperature. Right? Trying to decrease the temperature. Therefore system favors the system favors the net. This pen is bad, man. Net endothermic reaction. Net endothermic reverse reaction. Endothermic reverse reaction. Endothermic reverse reaction. Therefore, when endothermic reverse reaction is favored, NO2 concentration, you have to say, will increase. NO2 concentration will increase. Therefore, intensity of the brown color of NO2 will increase. So when you clearly say all of those, you are going to get 3 marks. All right. So 3 marks done. Done and dusted. Let's look at the next part. Let's go to the other side. Now, what is this? Below is the concentration versus graph for the reaction system. The graph was produced using the secondary data at 22 degrees. 22 degrees. Okay, what's that for? All right. When you are given a question like that, make sure you look at the x-axis time here, y-axis concentration. Now, you have to pay attention to something here. What is that? Here, the unit of concentration is times by 10 to the power minus 2. Always pay attention to the units. Pay attention to the units. If you don't pay attention to the units, you will get detention. All right, now listen. Okay. These are equilibrium concentration. Calculate the equilibrium constant at T1. What is T1? T1, in order to calculate the equilibrium constant, what do you need to do? You need to write the equilibrium expression. NO2 concentration squared over... Okay, you have to look at the expression, man. I didn't look at the expression. No, stupid me. Look at the other side. That is bad. It is N2O4 goes over the numerator is N2O4. N2O4 concentration over. Man, I got distracted there. Divided by NO2 concentration squared. What is this? NO2 concentration squared. Is that clear? So that is the K value. I got it wrong. So N2O4 concentration is what? As you can see, N2O4 is 1.5. This is equal to 1.5 times. Always make sure you put the right units. 10 to the power minus 2. Is that clear? 1.5 times 10 to the power minus 2 divided by, what is that? That is 5, isn't it? That is 5. 5.0 times 10 to the power minus 2 squared. Is that clear to you? Then they cancel out with 10 to the power minus 2. Then what is that? 1.5 divided by, this is 25 times 10 to the power minus 2. Then this will become what? This is 100, 1.5, 150 divided by 25, 6, isn't it? Two significant figures, 6.2. That's 6.0, not 6.2. Okay. What's the unit? When it comes to unit, this is m. This is m to the power squared, m minus, isn't it? All right. So we got that done. All right. That's simple. That's simple, isn't it? It's not that difficult. That's okay. What are the important things though? You need to check the units. Just check the units. All right. All right, that's done. And again, look at the mistake I did. I didn't look at, like, it was, since the question was in other side, I didn't double check the expression. See, you have to make sure you double check everything. Otherwise, I was going to lose the marks for nothing. All right, next question. At T2, volume of the system was halved. 3 marks. Oh my God. Volume is halved. Keeping the temperature is 22. Continue the graph to show this change would affect the reaction system. All right. We know what's going to happen. Volume is halved. You change the volume. So what happens when volume is halved? Mean volume is decreased by half, right? So volume is decreased. Then what is going to happen? You know when the volume is decreased? Okay. pressure is going to be doubled, right? Pressure is going to be doubled. So what would the system do? System partially oppose the change by, what would the system do? Trying to decrease the pressure. In order to decrease the pressure, system what? Favors the side with fewer particles, isn't it? Fewer particles. System is going to favors the side with fewer particles. What is SPOC? Don't write SPOC. Volume is halved, pressure is doubled, system partially oppose the change by trying to decrease the pressure. That is what it says. Is that clear to you? So then, in order to decrease the pressure, system should favor the side with fewer particles. Now look, what is the fewer particles? So write the reaction again, 2NO2. It's going to become N2O4, right? Look, double check. So N2O4. So in this case, system favors the fewer particles, mean this side 2, this side 1. So system favors the net forward reaction. System favors the net forward reaction, isn't it? Net forward, is that clear to you? Net forward reaction is the one that is going to be favored. Now, okay, now let's do this. So in this case, what do you need to do? We have decrease in the volume. When the volume is decreased, now there is no pressure, the concentration is going to be double. Look, concentration is equal to, okay, so it's here, concentration is equal to N over V. So when you are halving the volume, if you halve the volume, concentration is going to be doubled. Is that clear? All right, now we have to show that in the graph. Now this is 5. So this will go, all the concentration this is going to go up to 10. 2 times, look, this is clearly saying this is 5, it's going to go up to 10. This is what? This is 1.5, this is going to go up to 3. Oh, this is beautifully given. All right, then system will favor the what? Net forward reaction, isn't it? Because system is favoring the net forward reaction. When net forward reaction is favored, look at this. NO2 is used. So we are favoring the net forward reaction. So NO2 is going to be used. So therefore, NO2 concentration will go down. Now the coefficient is, look at the coefficient again. Coefficient is 2 to 1. 2 to 1. So NO2 change. We are measuring the change, going to go by 2. 2. So this is what? It's going to go by 2x. It's minus 2x. If it is going to go by 2x, make sure the equilibrium comes to this at the same time. This is going to go up by 1x. All right, so you need to write all right, 1x. Then we covered that question. Easy question. But you can be given a question like that. All right, I hope you understand everything. I'll see you again with another question. Equilibrium. Okay, see you. Bye.